chapter 1 through 7. And the whole thing was trying to think of how can I get that as the result after I take the derivative. Okay, if you can think about what you would have to take the derivative of in order to get this result, then you just found the antiderivative. Okay? So, let's see what you guys came up with. Did anyone, what do we get for x?
I've got 1/2.
Okay, you got what?
1/2.
You got 1/2 x squared. Okay, let's try that. If you take the derivative, you have 1/2 times 2x. The 2's cancel and you get just x. So good. Good. How about x squared?
1/3 x to the third.
Yeah. Okay, if you take the derivative, it's 1/3 times 3x squared. The 3's are gone and you got your x squared. All right? How about x to the 5th?
1/6 x to the 5th. Will that always work that rule?
What
Like
rule
the-
are we talking about?
Like the fact that you put it's the exponent goes 1 up and then it's 1 over whatever the new exponent is.
Okay, so you're saying if you have x to any power, you would make x to the next higher power,
Yeah.
and then you'd multiply it by,
1 over n plus
okay, 1 over n plus 1. That actually does work. The integral, what we're finding here is the antiderivative, or the integral of x to any power n with respect to x is x to the next higher power times 1 over that new power. Okay?
So, for a number 4, would it be to the negative third or to the negative first?
Well, let's think about that. Okay? Let me finish writing this. You can also write this as x to the n plus 1 over n plus 1. Okay? If you like writing it that way instead. Let's think about the pattern, though, here with the x to negative 2. What do we have to do the exponent?
Have your attention,
It has to be
please.
1 time.
Will the owner of a white Acura SUV in the middle of the road please remove it? Thank you.
Okay, so it's plus 1, so it's x to the negative 1 over negative 1.
Yeah, over negative 1, so
Or
it
negative.
just ends up being negative x to negative 1. Good. How about x to the negative 4th power?
X to the negative third over negative.
Yeah. Okay. How about x to the 1/3 power?
X to the 4/3 power.
Good.
Because it's
You add 1 to 1/3 and you get 4/3.
1/3. Oh.
3/4
Oh.
What?
times 3/4.
Times 3/4. Okay. This is where seeing it like this, it's the reciprocal of the new power, is kind of helpful. The reciprocal of 3/4 or 4/3 is 3/4. So it's 3/4 times x to the 4/3. Okay? Let's not play right now. How about x to the negative 1/2?
X to the negative, no,
X
x
to
to
the
the
1/2
1/2,
times 2.
yeah.
Yeah,
So
good.
2x.
Divided by 1/2, you flip and multiply, it's times 2. All right, good. Okay, so that's not too hard of a rule, right? You just gotta add 1 to the exponent and divide by the new exponent. Okay? Now, one aspect here that I want to take note of is this only works when n is not negative 1. Okay? Let's think about what the integral of x to the negative 1 power would be. Okay? Well, x to the negative 1 is 1 over x. So let's think backwards again. What has a derivative equal to 1 over x?
Natural.
What? The natural log of x. All right?
Wait,
the derivative of ln of x is 1 over x. So the integral of 1 over x would be the natural log of x. Okay? Now, all of these, if you remember, we talked about that constant of integration. Because if I took the derivative of ln of x, I'll get 1 over x. If I took the derivative of ln of x plus 5, I'd still get 1 over x. So we have this plus c here, and we could put a plus c here. On all of these, we could put a plus c. And what we're finding here, these are what are known as indefinite integrals. Okay? These are indefinite integrals that we're finding. Okay?
Why are they indefinite?
They're indefinite because we don't know what that c is.
But why do we need the plus c?
Because there's more than just one function that has a derivative equal to x. Okay? I could have 1/2 x squared, and that gives me a derivative equal to x. Or I could have 1/2 x squared minus 5. That also has a derivative equal to x. Okay? I could add any constant to this, and it'll still have a derivative equal to x. So that's how we kind of show all the possibilities. We put that plus c there. Okay? So that's actually our first two rules for integrals. X to a power, you add 1 to the power and divide by the new power. If you have 1 over x, the integral is ln of x. Okay? So those are our first two rules. Let's take a look at one other one. I didn't assign this one to you, but let's take a look at another one here. Okay? Let's start even simpler than the ones up here. If I just have the derivative of e to the x is what?
E to the x.
E to the x. So what is the integral of e to the x? E to the x, right? So, let's think about these ones up here, okay? What would have a derivative equal to e to the 2x?
E to the 2x.
Okay, let's think about that. What is the derivative of e to the 2x?
That's 2e to e to the, so e to the 1/2 x. 2e to the 1/2 x. I have no idea.
You're on the right track. You're right there.
1/2. 1/3 e to the 3x.
Wait, what?
1/2 e.
1/2 e to the 2x. Okay? If I were to take the derivative of this, I would get 1/2 times 2 times e to the 2x, right? Because the chain rule, that 2 comes out. So I need the 1/2 here to cancel out the 2's. Alright? So again, you kind of have that, we're multiplying by the reciprocal idea, right?
So is the next one 1/5 to the e to the 5x?
1/5 e to the 5x power. Yeah. Okay.
So then, well, what is that? Is that 1/2?
E to the 1/2 x.
2e to the 1.
2e to the 1/2 x. Good. Okay. E to the 1/100th x.
1 over 1. 100 over 1. 100 over 1.
There we go. 100 over 1, or just 100. E.
to the 1.
There we go. Okay. Is this making sense, everyone?
Yeah.
All right. Because if I took the derivative of just, say, e to the 1/2 x, if I took the derivative of that, I'd get 1/2 times e to the 1/2
It's
x.
the reciprocal, so you just put it over.
Yeah.
So then
To get rid of the half, I've got to multiply by the 2. So if I threw a 2 in here, I'd get to what I'm looking for. Okay?
So, wait.
So what's this? E to the pi
1
x.
over pi e to the pi.
Sure. Okay? And how about e to the x over 3?
3x. E to x.
3e to the x over 3.
Why did you forget about the x?
Well, just like these, I didn't make it 1 over pi x or 100x. I just used the coefficient. This is the same as
Okay.
1/3 x, right? So,
So for this one, instead of putting it over, you put it in front? Or okay, you're right.
you're multiplying by the reciprocal, or you could write it as, e to the pi x over pi, So the rule is actually kind of similar here. The rule for this, if I'm taking the integral of e to the kx with respect to x, I'm going to have e to the kx over k. All right? We're multiplying by the reciprocal of whatever that k was. All right? And then, of course, we've got the plus c. Now, one thing to remember here, okay? One thing is this only works when we have linear exponents. If I had like a 5x squared, this doesn't work. It doesn't work this way, okay? You have to use something called u substitution and everything. We're not going to be doing that, okay? We're just dealing with ones that are functions of a linear function, okay? So now we have 3 basic integration rules. We have the integral of e to the kx. We have the integral of x to a power, and we have the integral of 1 over x. Okay? So, any questions so far? All right, good.